Okay guys, welcome back. This is actually the final video on the videos on the standard enthalpies of chemical reactions. So in this video I will conclude about the series of standard enthalpies. So actually there are in fact four general enthalpies, actually minor enthalpies that I should define, and I will define about one of the major enthalpies that you will come across. So the first enthalpy I will define in this video is about the standard enthalpy of sublimation. You may have already known by now what is meant by sublimation, and for viewers who are not aware about what is meant by sublimation, you should know that sublimation is the conversion of a solid into its gaseous medium. Now for example, if some solid sodium is converted without converting into liquid completely into the gaseous state, we call that the sublimation. Sublimation is not the process of converting solids into a liquid state and then converting into a gaseous state. We completely convert a solid into the gaseous state, and heat should be provided for such a reaction. So the heat or the enthalpy required to change a solid in its standard state, 1 mole of a solid element, to 1 mole of the same standard element in the gaseous state is called the standard enthalpy of sublimation. So you can define that as the change in enthalpy that occurs when a mole of a solid element or a mole of a solid compound under the standard conditions is converted completely into the gaseous state. For example, if you take calcium here, as shown here, calcium in this solid state is converted into calcium in its gaseous state, and the energy required for such a reaction is as follows, and it's always positive because we have to give energy to perform such a reaction. So the second minor enthalpy change that I'll be discussing is about the evaporation. So these are actually enthalpy changes involving of phase changes. So evaporation is a change. You know that what is evaporation. So evaporation generally happens at the boiling point. Evaporation makes a liquid, some liquid, into its gaseous state. So sublimation is the conversion of a solid into its gaseous state completely without undergoing through a liquid. Evaporation is the process of a liquid converting into its gaseous state. So that generally happens in the boiling point. So we define the standard enthalpy of evaporation as the change in enthalpy that takes place when a mole of a liquid, we take 1 mole of a liquid compound or element under the standard conditions. So you have to take the standard conditions, is converted into 1 mole of the gaseous compound. So example, if you take bromine here, you can say that you take 1 mole and it's in the standard conditions and it's a liquid initially, and then finally you convert that to Br2 plus gas, and the vaporization here is 3091 kilojoules per mole. So that differs for different liquids. And the next enthalpy that I'll be talking about is the fusion. So fusion is the conversion between solids and liquids. So that is the reason as to why in the beginning I explained to you that these are minor enthalpies, because these are only defining about phase changes. So they can be defined for various elements. You know that there are various elements. They have the solid, the liquid, and the gaseous phase. They have different melting and boiling points. So the enthalpy of fusion should differ according to the melting and the boiling points and the initial conditions in which we are in. So as in the case of standard enthalpy of sublimation and the standard enthalpy of evaporation, standard enthalpy of fusion denoted as delta HF fusion FUS 5 or 0 is the change in enthalpy that takes place when a mole of a solid compound or element under the standard conditions is converted into a mole of liquid compound of the element. So in the case of sublimation, we converted the solid directly into the gas, not going through liquid, not converting into liquid. In the case of evaporation, we converted a liquid into the gas. And in the case of fusion here, we convert a solid into its liquid state. And if you take an example like aluminium here, you take aluminium in its standard conditions, it's a solid compound, and you take 1 mole of that solid compound, you convert into 1 mole of the liquid compound, and the energy required for such a reaction we have found that to be 10.7 kilojoules per mole. So that also varies between various elements and compounds. So the enthalpy then that I talked about some major enthalpy that I will be talking here. So the first enthalpy, the major enthalpy that I will be talking here is the standard enthalpy of atomization. So standard enthalpy of atomization is represented as delta H85 here. So standard enthalpy of atomization is sometimes similar to the standard enthalpy of bond dissociation, in that we break up bonds to form one mole of an element. For example, if you take chlorine here, you know that chlorine, you can take you actually have Cl2 gas in the standard state, so you take half a mole of Cl2 and then break it into Cl gas. So you take 1 mole of the element here, you convert that into an atom, or 1 mole of that element. So this is in the compound state, this is in the element state. So you convert that into an element, and the required energy for such a reaction has been found to be 121 kilojoules per mole. Similarly, you can do that for iodine as well. So in the case of iodine, you can find atomization in two ways. One way is to directly find the atomization method, and that's completely sometimes difficult. So what we find here easy is that we can easily do this using two steps. So that's using the Hess law. So using the Hess law, you can say that you can first convert iodine into